catch up with my social, and then we'll be good to go. On Instagram, there's an account called Enthuse Music. Don't know who they are, so I'm just reaching out to them, just saying hi and thank you, because they view and they like a lot of my stuff, and so that's highly appreciated. So whoever you are, Enthuse Music, thank you for supporting me. You guys will probably see a lot from me on social within today, so September the 9th. Give me some feedback, give me some comments, show me some love. Leave a comment, leave a like, share with people that you think might enjoy or might appreciate or might resonate with my content. That would be much appreciated. Without further ado, I guess we're back into the let's get back into the search algorithm portion of the video. Okay, so now let's actually get into implementing the search AI. So basically what a search algorithm does is it will take any given board. Let's say the AI in this case is X, right? So let's say the current game board is something like this, X, O, let's say there's another X played here, and then there's an O played here. So what a search algorithm will do, and let's say now it's X's turn, right? So X has to figure out where to go. So what a search algorithm will do is it will kind of simulate all future possibilities. Think of it as the search algorithm channeling its inner... think of it as the search algorithm is channeling its inner Doctor Strange, right? So then it will say, okay, well, you know, if one possibility, one possible future, one possible outcome is, it's my turn right now, and I am X. So one thing I could do is, well, I could just go here, and then that will stop Circle from winning. It'll always look at what's the fastest route to me winning, or what's the best outcome that I could have, either me winning or at least drawing and preventing the other player from winning, right? So it'll say, oh, okay, well, if I go here, then I'll stop Circle from winning. So, you know, it'll do more and more of it. So then it'll simulate, okay, well, then perhaps Circle goes here, and then, well, I win by going here. That's one possible outcome, right? Another possible outcome is that Circle actually goes here, and then X goes here. And so search algorithm will do all of these, and it will calculate all of these while it goes. That's one, right? And so in this case, let's say we don't know, so it'll simulate each and every single possible outcome from each board, and it'll come up with a number, it'll come up with a score. So if it wins, it'll give itself a score of 1. If it loses, it'll give itself a score of 0. And if it draws, it'll give itself a score of 0. And if it loses, it'll give itself a score of -1. So what it always wants to do is, and this is why it's called MINIMAX, it'll always try to maximize its score, knowing that its opponent wants to always minimize the score. And so, in effect, all we're really doing is we're just going through different board possibilities, right? Another board possibility is, let's say, for example, X does not go up in the corner there, rather X comes down here, because X is trying to set up some sort of, I don't know why X would go there. Circle can then go here in this possible world. And so now Circle has effectively minimized the score to -1, and so X loses. And so the AI will avoid scenarios like this, because at the end of the day, it always wants to maximize its score or always wants to win. And that's, in a nutshell, what MINIMAX is. So what we're just doing here is we're just having it get all the possible actions that it can take on an XY grid. Now what we'll look through is, okay, so, you know, after when it takes all these possible actions and it actually goes ahead and it considers one, what will the result, or what will the board then look like? So, you know, if the AI has the current board like this, and it is looking at future possibilities. Well, this square here is empty. So if I go here, what will the board look like? Well, this is what it looks like, right? And so then it can continue considering different possibilities and continue looking into different possible future states. Okay, so we're going to do a few things here. MINIMAX needs to, given any board, it needs to be able to tell whose turn it actually is for it to be able to go ahead and start doing its calculations. Okay, now we need MINIMAX to. We could probably just call the versus state check winner function. Yeah, shall we just do that? As we need the MINIMAX to know whether or not or who has won at the end of a given board, or at the end of a given simulated game. And another thing we needed to check is something called the terminal state, meaning that the game's over. So another thing MINIMAX needs to be able to do is it needs to be able to determine the utility of a board or calculate the score of a board. So once again, if it wins, it'll give itself a score of 1. If the enemy wins, it'll give the score of, or the utility of the game will be -1. If it's a draw, the utility or the score of the game will be, or that specific scenario or that specific future game is a 0. Okay, and so now we can start implementing the part where the MINIMAX is always going to find boards or find future states that maximize the value and also find future states that minimize the value. And so we're going to write those two functions separately. And then we're going to have one final function whose job is to always just cycle through based off of whoever's turn it is, either maximizing or minimizing the board. And our MINIMAX will be done. And so while we're building this, I'm actually just going to build in some optimization as we go along. So this optimization is called alpha beta pruning. Alpha beta pruning, basically what it does is it'll look over a few game states. So let's say the game has, let's say it's run through a few different scenarios. And this is what it has right now. And then it has, let's say, 3 more game states below it. 3 more game states below it. Okay. And so let's say at this state, the score here is 1, 1, -1, and the score here is okay. And so let's say that it's looking within this option. Now it knows that now this layer is always going to be the maximizing layer. So this layer is always looking for +1, right? This layer is the minimizing layer. So this layer is always looking for -1. So basically what alpha beta pruning is saying is that rather than going all in your Doctor Strange impersonation, what you can just do is, well, okay, so you found 1 here within this scenario very, very quickly. Well, that's all we're looking for. So there's no need to go through all these other ones. It's just going to be a waste of time. So let's just return the 1, and let's just put the 1 in this layer, right? So then there's 1 here. Same thing here, right? Okay, so we go through the first state, we found a 0. Okay, well, we could possibly do better than a 0. The second state, we found, oh, the second state can lead to a 1. And that's it. That's all we're looking for. All we're looking for is for a 1. And so we don't really need to consider that state. And so that is a way to optimize your search algorithm to make it much, much faster.
So just a little bit of context and just explaining this a little bit more. Essentially what I'm trying to say is because this player here, where's my mouse? This player here is always looking to maximize, and the best score it can get is a 1. So it cannot get a score better than a 1. So that's why if you find a score of a 1, that's the best score you can get. That's why it doesn't make sense to go look for other ones, because it's either going to be equal in terms of how good it is, or it's going to be worse, right? And so in this scenario, you know, you found a 0, which isn't a -1, but it's a 0, and so we can do better than that. That's not the highest score it can get. And so as soon as we hit a 1 for this maximizing player, well, that's the highest score it can get. So we don't really care about the other 1 that was here. And so that hopefully that just provides a little bit of context and a little bit of insight as to what I mean in this part of the video, and how MINIMAX, or sorry, how alpha beta pruning actually works.
I can't believe I didn't have it just return anything at all. Man, this Y and X count thing is going to be the death of me. Well, that's not what I wanted.
Just providing a bit more context for this part as well. So a search algorithm, because it's always trying to play an optimum game in tic-tac-toe actually should always end up in a draw. If both players are playing perfectly, there's no one player who would win in a tic-tac-toe game. And so here, when it's saying, you know, the winner is X, I said, well, it's not what I'm looking for. I know it's not working. It's supposed to end up in a drawn and perfect game, and you know, we'll see that later on during the video.
Oh, right. You have to give a deep copy of the game board, or else that is expected. Oh, that was not bad. I don't think this thing's working properly.
So yeah, just watch. As you saw, essentially I'm playing as X, and the algorithm is playing as O, or I'm crossing. He's a whatever I call it. I think I call it like a knot or whatever. And so because I went in the corner, it then went in the bottom. Essentially, the reason why I made the comment that it's not working as well as I had hoped is because it did not try to block me at all. It essentially I just walked all over it, right? And so that's what I mean by when I say it's not working.
Okay, well, let's just brute force test all of our functions, because clearly something's not working properly. Okay, so if I have so the utility function is working. Current player function. Okay, so that function's working. Like I'm missing something somewhere. Oh my god. Oh my god, I cannot believe that was the issue. Oh my. Ooh. Oh man, I'm pissed. Oh man, now I'm really, really pissed. Holy.
So the issue literally was it just wasn't passing in the active game board to the algorithm. I wasn't feeding it with the active game board, and so I think it was reading off. Again, this is a while ago, but I think it was reading off. I don't know what game board it was reading off, but essentially it just wasn't the right game that it was, like game state that it was reading, and so that's what was causing. So what was causing issues. It took me like 2 hours, 2 whole hours of my life just to figure that out. Just watching this pisses me off again. It's like I have PTSD from back then, man.
Oh my god. Oh my god. There's no way that happened. I spent hours just for that? I cannot, I am in shock. I am still in shock. Oh no, there's two. Oh man. Oh, finally. We have MINIMAX up and running. And yeah, it is unbeatable as you'd expect it to be.
So another thing that another thing I was looking for was I did some research on what the optimal moves would be for X and for O. And so if X goes in that top corner, like I did in the video, then O must go in the center. If it does not go in the center, it's going to lose. And so that's how I knew whether or not the algorithm was working, just based off of its very first move. If it goes anywhere other than the center, if X starts in any of the corners and circle goes anywhere other than the center, it's not playing optimally, and that means that the MINIMAX algorithm isn't working.
Okay. Yeah, this is the name of tie. Holy. What happens when you put MINIMAX against MINIMAX? Yeah, I actually want to watch that. Let's see, so player 1 is equal to a MINIMAX. And player... I actually want to watch what happens here. Why the hell did that not play? Oh, I think I know why. Wow. Wow. Just wow. That was truly painful. I want to witness this. Oh, yeah. Yeah, if it's doing that, then local alpha is... So then if we go here, that's absolutely crazy.
You guys want to know something that's funny about this part? What's funny about this is I spent maybe like 10 minutes trying to implement a timer system. So because, you know, like in for example chess competitions, both players have like a time limit, right? So you can't just sit there and like in an international chess competition and take 50 minutes just to make one move, and so there's a time crunch. So that's what I tried to simulate in this game as well, but I gave up. I think I spent 10 minutes, realized it was going to be too much work, and I was way over my head, and I just didn't understand half the concepts they were talking about for implementing the timer, so I just gave up on it.
So yeah, I polished it and I slowed it down a little bit so one can see what's going on. And I have the MINIMAX going against itself. It's pretty interesting, I feel. And this is the result. So I guess X started in the bottom corner. It took it a while, but I guess it figured that's probably the best place to go. Circle or not, determined that going in the middle is probably the safest. And yeah, this is what transpired afterwards. They pretty much play like this every single time. And that's kind of why normal tic-tac-toe is way too simple because it's something that the algorithm can solve pretty easily. Let's see how it does against our naive AI. Yeah, so pretty much the same result, huh? Yeah, pretty much the same result. What happens if we change them around? What happens if our naive AI goes first? So puts the MINIMAX AI on the defense. Let's see what MINIMAX does. Huh, interesting. Yeah, I'm not sure why MINIMAX did that. I think MINIMAX could have won if he really wanted to. You know what? Let me implement a pause feature. Just so I can pause the game whenever I'd like. Okay, let's see if we can implement the pause. It's clearly not paused. Okay, I see what's wrong. Should actually be here. Okay, there we go. Now we truly have a pause. Seems as if we're stuck though.
Man, this pause feature was such a hassle. It's like, I don't know, man. It was so tough to even get it implemented. And then, as you just saw right now, after the game does pause, it just doesn't unpause. And so this took me way longer than it really needed to, but
So I don't quite understand why MINIMAX even made that move. Yeah, I don't think that was a smart move, to be honest with you. Actually, no, it kind of was, depending on. Yeah, it kind of was an okay-ish move. And so, well, naive just is trying to win, and as we expected, MINIMAX will cut him off. And then naive will try to win again. I think this time on the diagonals. Oh, he went on the verticals. Yeah, this game's going to be another tie. Now it's pretty interesting. Now what happens between these two guys if you take this and you turn it into a 4x4? That'd be interesting to watch. See if either of them can even handle a 4x4. Yep, now we're just gonna have to wait for. And here he's taking his time, just planning one move, huh? I think our guy is really stuck here. Yeah, I think I need to optimize this. Yeah, this is just not gonna work. Once this goes full 3D, this is not going to work at all. So we either have to optimize it further, or we have to introduce heuristics into this into the game.